Hello. Today we're going to talk about the last section of Chapter 3, which is solving radical equations. And this is your notes, page 10. In order to solve, remember when we're solving equations, you're going to have to tell what x is equal to in the end. And in order to solve equations that contain radicals, the first step is to isolate the radical. That's really important. It's just like when we were solving absolute value equations, we had to isolate the absolute value first. It's the same deal if it's not already done. You have to go through step 1. The second step is to square both sides. Or if it's a cubed root, you're going to cube both sides. Then you're going to solve for x. You're going to tell what x is equal to. Sometimes it's more than one thing, but you have to list out what the x values are. And then you have to check, because you could get extraneous solutions, just like in the other equations we've tried to solve before. So what I mean by these 4 steps is the first step is to isolate the radical, and this one already is because it's all by itself. Step 2 says square both sides. To get rid of a square root, you square it. It's the opposite. So the square root of x squared is just x, and 5 squared is 25. So there's your answer. X equals 25, and to check, CH means to check. You're just going to put 25 back into the original equation, and is the square root of 25 equal to 5? Well, yeah, that checks. Part B, square both sides. Squaring a square root just leaves us with what's underneath, the radicand. 10 squared is 10 times 10, 100. Divide both sides by 5, and you get x is equal to 20. And then the check says, is the square root of 5 times 20 equal to 10? 5 times 20 is 100. Is the square root of 100 equal to 10? Well, yes, 10 equals 10, so that one checks. In part C, well, this radical has to be isolated because you can't have a plus 2 next to it, so the first step is to subtract 2 from both sides, just like if it were an absolute value problem. So you get the square root of 4x dropping down, the 2's cancel out, and 8 minus 2 is 6. Now we can square both sides. The square root of 4x squared is just 4x. 6 squared equals 36. And then if you divide both sides by 4, 36 over 4 is equal to 9. So now we have to check. In the original problem, don't check in anything else except the original. So does the square root of x equals 9? 4 times 9, that's a 4, hopefully you can read that. 4 times 9 plus 2, does that equal 8? Well, 4 times 9 is 36. Does the square root of 36 plus 2 equal 8? The square root of 36 is 6. Does 6 plus 2 equal 8? Well, yeah, 8 equals 8, so that one checks. So make sure you check these. The next one, letter D, you have to isolate that radical, so you're going to subtract 7 from both sides. 7's go away, and you're left with the positive square root of 3x. 1 minus 7 is negative 6. Now you're going to square both sides. Put parentheses around this because negative 6 to the second power is positive 36. Negative 6 times negative 6 is 36. So when you divide both sides by 3, 36 over 3 is 12, so x equals 12. So now we're going to check this. And the check says, does 7 plus the square root of 3 times 12 equal 1? Remember, you check in the original one. So does 7 plus the square root of 3 times 12 is 36? Does that equal 1? The square root of 36 is 6. 7 plus 6 is 13. 13 does not equal 1, so x equals 12. Lightly cross that out and write ext. It's an extraneous solution. There is no solution for this problem. You can put x equals no solution. That means an empty set. On letter E, this is a cubed root, so you're going to have to cube both sides. So the cubed root, cubed, just leaves us with 5x plus 75, and 5 times 5 times 5 is 125. Don't be fooled, this is not 15. Subtracting 75 from each side leaves us with 5x equaling 125. That looks like it's 50. And divide both sides by 5 and you get x equals 10. So now when you check this, does the cubed root of 5 times 10 plus 75, does that cubed root equal 5? 5 times 10 is 50. 50 plus 75 is 125. Does the cubed root of 125 equal 5? Well, you can check on your calculator if you want, but it does. 5 equals 5, so that one checks, so that is the answer. It's a good idea to write down the ANS or EXT. If you have a coefficient, this next section, if there's a coefficient with the radical, like a 2 out in the front, you square or cube the coefficient also. So this radical is isolated, so what you're going to do is you're going to square the left, and when you square the right-hand side, you have to square the 2. So this becomes x squared equals 2 squared, which is 4, the square root of x squared, which is just x. And since this is quadratic, you have to set it equal to 0. So you have to subtract 4x from each side. And this becomes x squared minus 4x equals 0. Don't divide by x because you'll lose an answer. This factors, it has a GCF. Be careful, this is not x plus 2 and x minus 2. That's one of the things that fools a lot of people. This has got a GCF, right? The greatest common factor is x, and you're left with x minus 4. So you have two answers here. This x value equals 0, and this x value is equal to 4. So actually now you have two checks to make. Let's check x equals 0 first. So when you put it in the original equation, does 0 equal 2 times the square root of 0? Well, the square root of 0 is just 0, so 0 equals 2 times 0, which is 0. That one checks. So x equals 0 is an answer. Does x equal 4? Let's check. X equals 4. So in the original equation, does 4 equal 2 times the square root of 4? Does 4 equal 2 times the square root of 4 is just 2? Well, 2 times 2 is 4. 4 equals 4. That one does check. So you have two answers with this. You have x equals 0 and x equals 4. And if you want to be fancy, you can put it in little brackets and say 0, 4 are your answers. Okay, on this next one, the radical is isolated, so you're going to square both sides. So square 3x, and you get 9x squared. Don't forget to square the 3. That's something that people forget a lot. And when you square the right-hand side, 2 squared is 4, and the square root of 3x minus 1 is just 3x minus 1. Square root of 3x minus 1 squared. So square both parts. The next thing you're going to do is distribute the 4 in through the parentheses. So you have 9x squared is equal to 4 times 3x, 12x. 4 times 1 is 4. So this is a quadratic. I'll put a Q there for quadratic because x is squared. So that means you have to bring the other terms to the left and set it equal to 0. 9x squared minus 12x plus 4 equals 0. Remember, subtract 12x and add 4 to both sides. This is factor in, factor out. So 9 times 4 is 36. The factors of 36 that add up to negative 12 are negative 6 and negative 6. So I'm going to continue to factor. This is 9x minus 6, 9x minus 6, and don't forget you have to divide it out by 9. But the 9 is too big to go into 6, so you have to split this up into 3 times 3. So I'm just going to pull the rest over here. When you divide 9x minus 6 out, you're going to be left with 3x minus 2, and the same thing goes over here. 3x minus 2 equals 0. So you're going to solve this for x by saying 3x minus 2 is equal to 0. Add 2, 3x equals 2. Divide by 3, x equals 2/3. Then you're going to get the same answer on the other side because it's the same factor. So now we have to check, and that's a little bit trickier. You can use your calculators if you want, but you have to check in the original equation. So it's 3 times x, which is 3 times 2/3. Does that equal 2 times the square root of 3 times 2/3 minus 1? That's the original equation. 3x equals 2 square root of 3x minus 1. Well, 3 times 2/3, you can do your calculator, or you just can cancel those 3's out. So this says 2 is equal to 2 times the square root of, this is 2 minus 1. So 2 equals 2 times the square root of 2 minus 1 is 1, and the square root of 1 is just 1. So 2 equals 2, and that checks. So 2/3 is the answer. That one was kind of tricky. Letter H. These are the toughest problems of all because they have a binomial on one side of the equal sign. X plus 2 is a binomial. It has 2 terms. When you subtract 4 from this one, you're going to get x minus 4. That'll be a binomial. So you're going to have to FOIL. A lot of people forget this. A lot of people forget this. So make sure you FOIL these when you square the left and square the right. Remember, we're squaring both sides. So x minus 2 squared is actually, or x plus 2 squared is x plus 2 times x plus 2, and that's going to be a FOIL. The square root of 3x plus 16, or squared, is just 3x plus 16 when you square a square root. So this is FOIL. X times x is x squared. X times 2 is 2x. X times 2 is 2x. 2x plus 2x is 4x. And 2 times 2 is 4. When you get done FOILing that, you're going to get x squared plus 4x plus 4, and that is equal to the right-hand side, 3x plus 16. Remember, this is a FOIL. This is a quadratic. I'm going to put Q for quadratic because x is squared, so that means you have to subtract 3x and 16 from each side. And you get x squared plus x minus 12 equals 0. Factor it. Factors of negative 12 that add up to 1 are positive 4 and negative 3. So x has 2 answers. X equals negative 4 here. X equals positive 3 here. But we don't know if those are actually the answers until we check. So let's check. Let's check x equals negative 4 first in the original equation. So this says x plus 2, which is negative 4 plus 2. Does that equal the square root of 3 times negative 4 plus 16? Negative 4 plus 2 is negative 2. 3 times negative 4 is negative 12 plus 16. Does negative 2 equal the square root of negative 12 plus 16 is 4? Well, the square root of 4 is 2, and 2 does not equal negative 2, so this does not check. DNC does not check. So x equals negative 4 from the beginning. Lightly cross him out. He is an extraneous solution. Now the next thing we're going to do is check x equals 3. So does 3 plus 2 equal the square root of 3 times 3 plus 16? Well, 3 plus 2 is 5. 3 times 3 is 9. 9 plus 16 is 25. Well, the square root of 25 is 5. So that does check. So x equals 3 is our only answer. Negative 4 is extraneous, not just because it's negative, but just because it didn't check. Okay, and then this last problem on the page, when you have x equals 4 plus something, you have to isolate the radical first. We haven't done that in a while, but this one you have to isolate because you have to get this radical by itself. So you're going to subtract 4 from each side. Don't forget this, it's really important. So that leaves you with x minus 4 is equal to the square root of 2x minus 8. Now that the radical's isolated, you have to square both sides. And x minus 4 squared is x minus 4 times x minus 4. And the square root of 2x minus 8 squared is just 2x minus 8 without the radical. Well, if you FOIL this, x times x is x squared, x times negative 4 is negative 4x, and you got another negative 4x. Negative 4x and negative 4x is negative 8x, and negative 4 times negative 4 is positive 16. So now you're going to set this equal to 0. This is a quadratic equation, so you're going to subtract 2x and add 8 to both sides. And what you're left with is x squared minus 10x plus 24 equals 0. The factors of 24 that add up to negative 10 are negative 4 and negative 6. So it looks like we've got two answers coming out of here. It looks like we've got x equals 4 and x equals 6, but we don't know until we check. So let's check. First, let's check x equals 4 in the original problem, remember. So does 4 equal 4 plus the square root of 2 times 4 minus 8? Does 4 equal 4 plus the square root of 2 times 4 is 8, 8 minus 8 is 0. Well, the square root of 0 is just 0, so 4 does equal 4, so that one checks. X equals 4 is one of our answers. Now let's check x equals 6. So when you plug in 6 to the original equation, does 6 equal 4 plus the square root of 2 times 6 minus 8? Does 6 equal 4 plus the square root of 12 minus 8 is 4? Does 6 equal 4 plus the square root of 4 is 2? Well, yeah, 6 equals 4 plus 2, 6. So this one actually has two answers to it. Oops. A and S for answer. So we have two answers, 4 and 6. So if you want to be fancy and put them in curly brackets, 4 and 6 are both our answers. Over here on the next page, if you have a radical on both sides, that's okay. That's actually an easier situation because when you square a radical, when you square both sides, the radicals just go away and you're just left with 5x minus 3 equals x plus 13. This is not quadratic, so you're going to subtract x from each side and add 3 to both sides, and you get 5x minus x is 4x. The 3's go away, and 13 plus 3 is 16, so x is equal to 4. And when you check that, does the square root of 5 times 4, which is 20, 20 minus 3 is 17, this is a check. Does the square root of 17 equal x plus 13, 4 plus 13, 17? Yeah, that one checks. That's a quick check. Quick check. I've been there. Letter K, you're going to move one of those radicals over to the other side. So this negative, you're going to have to add the square root of t plus 25 to both sides so you can get a radical on both. So this becomes 2 times the square root of t plus 7 is equal to the square root of t plus 25. And now when you square both sides, remember you have to square the 2. 2 squared is 4. And that radical just goes away, so it's just left with t plus 7. And then when that radical goes away, you're just left with t plus 25. Make my t's all the same, I guess. Now distribute. 4 times t is 4t. 4 times 7 is 28. T plus 25. Subtract t from each side. Subtract 28 from each side. And you get 3t is equal to 25 minus 28, that's negative 3. So when you divide both sides by 3, you get t is equal to negative 1. All right, let's see if that checks. Check t equals negative 1. So in the original equation, does 2 times the square root of negative 1 plus 7 is 6, minus the square root of negative 1 plus 25 is 24. Does that equal 0? Well, the square root of 6 can't be simplified, but 24 simplifies into 4 times 6. And when you reduce the square root of 24 down and pull that 24 out, we're going to get 2 square root of 6 minus the square root of 4 is 2. We're left with the square root of 6. And when you subtract anything from itself, you get 0 equals 0, so that one checks. So t equals -1 is the answer to that problem. Now the next ones are on your own, and I'd really like for you to do these on your own. I'm just going to take you through this first one. I'm going to talk you through this first one. Make sure you cube both sides, and when you cube this, it's just going to leave you with 9x equals 3 cubed. And remember, 3 cubed is not 9. 3 cubed is 3 times 3 times 3, which is 27. So remember, cube both sides here. On number 2, when you square the left, make sure you square the 2 and get 4x. And when you square 6x, you'll get 36x squared. So be careful on that squaring. On number 3, you're going to have to subtract 2 from the left and the right. So you get an 8 over here. And then you'll get 3x minus 16 equals 8 squared. On number 4, you have a plus 9 here. You're going to have to subtract 9 from each side. So the 9 will go away, and 11 minus 9 is 2. So when you cube that, you're going to get 2x plus 4 equals 2 cubed. This one, remember, just square both sides and the radicals go away, and you're left with a quadratic equation that you'll be able to solve. And this last one is like the last problem that I just did. Move that 2 square root of x plus 4 over to the other side, so you have 2 radicals that you can square, and you'll just be left with x squared plus 4 equals 4 times x plus 4, because you're going to have to square that too. So try these on your own. I'll check them in class tomorrow. Make sure that you've done all 6. And that's it for tonight. I'll see you in class. Oh, no, that's it for chapter 3, because that's the last page. So I'll see you tomorrow in class.